This example asks us to solve absolute value of 9x plus 1 equals the absolute value of 6x plus 4. When you have one absolute value set equal to another value, you break it down into two cases, and they're oftentimes called equal and opposite. Equal and opposite. And what that means is the equal case, you just drop the absolute values. 9x plus 1 equals 6x plus 4. Easy enough. For the opposite case, you leave the first absolute value alone, the one on the left, so this is still 9x plus 1 again, but then you say equals negative parentheses 6x plus 4. Alright, so that's the big deal. You need to put a negative on the second case, and you need to add these parentheses in. Alright, that's the key. So a lot of times when students do these, they just leave this opposite case out altogether, but that's half of our solutions. So you're only getting half the points, half the credit if you leave this step out. You want to make sure you get all your answers in here. Okay, solving for x. Let's get all our x's on the same side. That gives us 3x over here. Subtract a 1 equals 3, so x equals 1. In this second equation, I'll distribute this negative through. That gives us 9x plus 1 equals negative 6x minus 4. Alright, again with getting all the x's on one side, I'll add 6x to both sides. That gives us 15x, and then subtracting the 1 from both sides gives us negative 5 over here. Divide both sides by 15 to get x equals negative 5/15. But that simplifies down to negative 1/3. There we go. So we have 1 and negative 1/3. Two answers to that one. These will almost always have two answers. Sometimes they'll have one, sometimes they'll have none. Let's try B. We have 4n plus 5 equals 4n plus 3. We do the same thing. Set it into two different cases here, the equal case and the opposite case. In the equals case, we just drop the absolute value, leave everything else alone. So we have 4n plus 5 equals 4n plus 3. Alright, in the opposite case, we leave the first one alone, 4n plus 5, the left absolute value alone, equals negative parentheses 4n plus 3. Alright, so that gives us two different equations to work on. In the left one, things are getting a little weird. Right? We can subtract the 4n from both sides, but that gives us 5 equals 3, which is blatantly untrue. So this entire one is thrown out, right? That's false. When I subtracted the 4n from both sides, they canceled out. We're left with 5 equals 3. False. Okay. On the other side here, we have 4n plus 5. Let's distribute our negative. So that gives us 4n plus 5 equals negative 4n. That's going to help us. Minus 3. Adding 4n to both sides gives us 8n. Subtracting 5 equals negative 8. Then dividing both sides by 8 gives us n equals negative 1. So only one answer to that one. Let's add in a part C. Here we have the absolute value of 2r minus 6 over 5 equals the absolute value of negative 2. Okay, well, we'll break it down into our equal and opposite again. Here, so we'll have equal and opposite. Alright, the equal case, we just drop the absolute values. So that gives us 2r minus 6 all over 5 equals negative 2. And in the opposite case, 2r minus 6 all over 5 equals negative, parentheses, negative 2. Right? You just add in a negative, add in the parentheses, and go with it. Okay, well, here we multiply up by 5 on the bottom, right here. So that gives us 2r minus 6 equals negative 10. So adding 6 to both sides, 2r equals negative 4, which tells us that r equals negative 2. Okay, one down. On the right side here, negative 2 is positive 2. And then we multiply up by 5, we'll get 10. So this gives us 2r minus 6 equals 10. Adding 6 to both sides, 2r equals 16. Dividing by 2, r equals 8. There we go.